All right, my friends, today I'm going to be helping you with your reflections homework. And so we're going to be looking at the mathematical transformation called a reflection, which some of you will have learned at one point as a flip. Because if we remember looking at ourselves in the mirror, when we wave with our left hand in our mirror, our reflection in our mirror is actually moving their right hand, which means whenever we look in a mirror, everything is flipped or the opposite. So when we go left, it's right, right, it's left. And the same thing happens with our 2D geometry. When we reflect things through, it becomes a flip. Okay, it changes its orientation. And so when we're looking at reflections, there's always going to be some kind of line, either dotted or straight, and it's going to be called the line of reflection. And that's a fancy way of saying here's where the mirror is, here's where things are going to get flipped. And so what we should know is when we look into a proper mirror, we should be kind of what we call in proportion. If I'm kind of right at the close to the mirror, then my reflection should be right close to the mirror. If I'm really far away from the mirror, then my reflection should be really far away from the mirror. And the same thing goes with 2D geometry. So if I create a little flag here, for example, and put a little, there's my flagpole, my flag. When I reflect it here through my line of reflection, it should not change its size, should not change its shape, but it will change which way it points. So right now my flag is over here on the left side of my reflection line. When I flip it, it's like a pancake. I'm going to flip it over here, and so it should end up with my flag being onto the right side of my flagpole. So again, I'm going to teach you those point-to-point strategies like I taught you with translations. I'm going to start with my flagpole, so I'm going to translate this black line. And I want to make sure that it's the same distance from my line of reflection. My reflection is as the original. So this is the original. And over here is going to be the reflection. Just so you can kind of get where I'm going here. So I want to make sure that my line's the same distance from here and it's the same size. So what I'm going to do is take the end of my line and figure out how far it is. So I'm going to count the spaces that goes from here to my line of reflection. So if I count, I can see 1, 2, 3, 4, 5 spaces from my original to my line of reflection. And so now when I'm making my reflection, I want to make sure it's the same distance. So I counted 5 to get to here. I'm going to count 5 again. 1, 2, 3, 4, 5. So the top of my flagpole and my reflection is going to be here. I'm going to do it again with the bottom. Okay, I'm going to count. It's 1, 2, 3, 4, 5 spaces from the line of reflection. Count it again. 1, 2, 3, 4, 5 spaces over here. And I'm going to connect the dots. And there's my flagpole. And so you can see there's 5 squares between here and here. There's 5 squares between here and here. So they're the same distance from our line of reflection. Now I've got to reflect this flag. Okay, and it's got 2 corners. There's a corner up here and a corner down here. So I'm going to count how many spaces it is. I'm going to make sure when I do it, I'm not going to go up or down. We want it to be on the same horizontal line here. So now I'm going to count 1, 2, 3, 4, 5, 6. So now I know I'm going to count 6 on the other side. 1, 2, 3, 4, 5, 6. Do it again with the bottom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and if I connect the dots, here's my flag. And does it look flipped? Does it look like I took it and went and flipped it over? Yes, it does, because now my flag used to point left. Now it's pointing right. Okay, so that's how we know we have flipped it. So let's see if we can squeeze another one in on this paper. Nope, so let's get a new one going on here because I don't want to distract you with the ones above. So let's make this disappear. So now let's try something a little bit trickier than a flagpole. So again, we're going to have our line of reflection. So here it is. Okay, so that's where my mirror is going to be. Okay, and this time instead of reflecting a flagpole, I'm going to reflect a triangle. Sorry, my friends, I'm just making sure that my triangle that I'm drawing here matches the one that I've got as a prop over here. So hopefully that matches. Let's see. So there's my triangle, okay? And now I've got to reflect it over here. And so what we're doing with the reflection is, if you can visualize it, here's my little triangle, is we're picking it up, flipping it over, and making sure it's the same distance. So when we were working with some friends, we'll see friends who have put their triangle too close. See, there's a huge space here and not a big space there, or they'll put it way too far out, or their triangle might not be the same size. So one trick that you can do, and one that I would encourage you to try, is you can try the cutting out method. Flip it over so you know that this is what it's going to look like, and all you've got to do is count the spaces. So if I get my pen back, there's 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 spaces. Put it right here, and I can just go hold my triangle steady and trace around it, and that'll put it in the right spot. Because if you look at it right now, they're the same size, they're the same shape, they're the same distance from our line of reflection, and one's pointing left, one pointing right. So we know we've flipped it. If that doesn't work for you, we can still go back and do that point method. So here, let's reflect this point. It's 1, 2, 3, 4, 5 spaces from the line of reflection. 1, 2, 3, 4, 5 spaces from reflection. So from that point, reflected is over here. Do it with another point. Let's try this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's that green point translated. And now let's do our last one. Let's do this one as blue. Okay, so let's move this one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there it is translated here. So now we've got the 3 corners of our triangle. So now I can play connect the dots. And if we look at it, the really cool thing now that I've got my little prop is that we can just go and say, okay, there it is originally. And I can play the flipping game, flip it and reflect it, and look at that, it matches up perfectly. So we know we've done it correctly, and we can double check that they're both those 5 squares from here to here and here to here. Is that the most important thing with the reflection? Is the shape doesn't change. The size of the shape doesn't change. It doesn't get bigger, doesn't get smaller, doesn't get skinnier, doesn't get fatter. The distance from that line of reflection stays the same, because it should always be the same unless you're in a funny mirror like at the circus or a fair. Your mirror should always reflect you the same way that you are in position to the mirror. So we don't want that shape closer or further from the mirror than the original is. So hopefully that helps you understand reflections and helps you with your homework this week.